the 2018, this is Leaving Cert Higher Level. This is paper 2 and this came up as question 7. So a section of garden railing is shown below. The section consists of 9 cylindrical bars labelled A to I with a solid sphere attached to the centre of the top of each bar. So the volume of each sphere from B to E is 1.7 times the volume of the previous sphere. So we have for A, B, C, D, E, so the volume of each is 1.75 times the volume of the previous. So the radius of sphere A is 3 centimeters. So if I want to get the volume, so I want to get the sum of the volumes of 5 spheres. Well, I'm first going to have to get the volume of sphere A. So this is A, B, C, D, E, and it has a radius of 3 centimeters. So the volume is going to be 4 over 3 pi or cubed. So that's going to be 4 over 3 pi 3 cubed. So the answer for that is 4 over 3. I'll leave it in terms of pi for now, cubed, and then I get 36 pi. So the next one, so the total volume is going to be A, which is 36 pi, plus B, which is 36 pi by 1.75. So that's A, that's B, and then plus C, which is 36 pi by 1.75 squared, and then plus D, which is 36 pi by 1.75 cubed, and then E, which is 36 pi 1.75 to the power of 4. Now I could actually just work this out on my calculator, but I think it's easier to do the sum of the geometric sequence series because I think it will save us some time. So Sn is equal to A 1 minus or to the power of n 1 minus or. So A is 36 pi. The ratio or is 1.75, and then n, there's 5 terms, so 1, 2, 3, 4, 5. So it's going to be A, which is 36 pi, and then 1 minus or, which is 1.75, to the power of n, which is 5, all over 1 minus 1.75. So I'm just going to work this out on my calculator. So 36 pi and then 1 minus 1.75 to the power of 5, and then that's all over 1 minus 1.75, and then I get the volume of all of them together is 2324.238. so 2324 centimeters cubed is going to be the volume of each of them, so of all them together. So that's the volume, and then it says, so that's part A, and then it says the surface area of sphere E can be taken to be so the surface area of sphere E can be taken to be 503 centimeters squared. So the surface area, so I know the formula for the surface area. I'm just going to get it now. Formula for the surface area is 4 pi r squared, and we're told the surface area is 503 centimeters squared, so it's going to be 4 pi r squared. So I can get the radius from this, so I can divide both sides by 4, so 503 divided by or I can divide both sides by 4 pi would probably be easiest. So r squared is 503 over 4 pi. So if I want to get r, it's going to be the square root of 503 over 4 pi. So the square root of 503 over 4 pi, and then I get that the radius is for this case 6.326, and then it says correct to 1 decimal place. So, well, they want the height. So I'm just going to put the radius corrected 2 decimal places. So 6.33 centimeters. So then what I want is, so they said the height of the railing, the whole railing here is 1.2 meters. But I know that the radius of this is 6.33 centimeters. So so if I want to put that in meters, because this is in meters, so the radius is going to be 0.063 meters. So if I want to get the diameter of that, so it's going to be the diameter is going to be 0.063 multiplied by 2. 0.063 multiplied by 2, and then I get the diameter is 0.126 meters. So this bit here is 0.126 meters. So if I just want to get the height of the bar, it's going to be, so the height is going to be 1.2 take 0.126. So 1.2 take 0.126, and then I get the height is equal to 1.074 meters, and that is our answer for that. So I'm just going to underline all the answers that I had so far. And then it says the radius of each bar is 1 centimeter. The volume of the bar A is 7. So the heights of the bar form an arithmetic sequence. So the radius of each bar is 1 centimeter. So the volume of the volume of bar A. So the heights of the, so I'm after getting, so the heights of the bars, so A, B, C, D, E. That means if they form an arithmetic sequence, it's going to be the same difference between each of them. So I'm just after getting the height of bar E. So the height of that is 1.074. And then it says the volume of bar A. So I'm going to have to get the height of it. So the volume of bar A is, and they're dealing in centimeters, so I'm going to deal in centimeters for this volume question. So the volume of a cylinder is pi r squared h, and they tell me it's 71.3 pi, and that's equal to pi, and then I just have to get the radius of each bar. Told the radius is 1, and then I just have to get the height. So I can divide both sides by pi, so 71.3 is equal to the height. So in meters, because we're dealing in meters for the most part, so I'll put the height is equal to 0.713 meters. So that's the height of bar A. So 0.713 meters. So, well, say this is our difference. There's 1, 2, 3, 4. This plus 4 of the differences is equal to this. So 0.713. So 1, so we'd have to add 1, 2, 3, 4. Plus 4, let's call it x, the common difference, is equal to 1.074. So 4x is going to be 1.074 take 0.713. So 1.074 take 0.713. Then I get 4x is equal to 0.361, and then I have to divide both sides by 4. So divide by 4, so 0.6, so 0.713, and then I get so if we put 4, I get x is equal to 0.09025. So it said, so that's going to be the distance, the kind of how much it increases by each time. So I might say just keep it as they want in centimeters the height of each bar. So I'm going to keep it as centimeters actually for now. So this is 71.3 centimeters, and the jump for each of them, so if I have that in centimeters, it'll be 9.025. So each of them will have to add on 9.025. So 71.3 plus 9.025, and then I get 80.325. 71. 25, and then add 9.025 to that, and then I get 89.35, and then add 9.025 to that, and I get 98.375. So the height of A is this is B, C, D, and they want it all in centimeters, so I'll just put this in centimeters. So that'll be 107.4 centimeters. So that's going to be there, the heights of them all in centimeters. So the heights of the bars. So they're my heights, and then so that's my answer for that. And then there is a wall. So the next part of the question, we're told there is a wall on each side section of the railing as shown in the diagram. So I'm just going to draw kind of roughly what I see. So this is say I'm not sure whether I should deal in meters or centimeters, but I'll just draw in what they have drawn. So the whole thing here is, I might go with meters, 1.5 meters, and then from here to here is 20 centimeters or 0.2 meters, and from here to here is 0.2, and then the distance between each of them is identical. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 altogether, and each of the bars has a radius of 1 centimeter. So radius of each of the cylinders, because these are all cylinders, is equal to 1 centimeter. So the distance from the wall, so the distance from the wall to bar A is similarly the distance from the other wall to bar I. The wall to bar A. So yeah, so the radius, the distance, the gap between them is each identical. So they asked me to find the size of the gap. So firstly, I might get, because the gaps are identical, I might just get the distance from here to here first. So that's going to be in meters, 1.5 divided by 2. So that's going to be 0.75 meters, 0.75 meters. Or actually what I might do first is 1.5 minus 0.2 minus the 220 centimeters. So 1.5 minus 0.2 minus 0.2. So then I'll just get then I'll just be left with the length in here. So 1.5 minus 0.2 minus 0.2. And then I get 1.1. So 1.1 is, say, this distance here. But each of these has a radius of 1 centimeter. So the radius is 1 centimeter. So 1 centimeter, or I can write that as 0.01 meters. So the diameter of each of the bars is going to be 0.01 by 2. So it'll be 0.02 meters. So the whole length across here is 1.1, but then the actual bars take up 0.02. So I'm going to subtract that to find the size of each of the gaps, and then divide by the number of gaps, 0.02. So I get 1.1. So I actually have to, because this is a gap of 1, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the radius is bar. So I have 9 bars. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to multiply 0.02 by 9 to find out how much the bars take up. 0.2 by 9. And then I get 0.18. So that's the space the bars take up. So the whole of it is 1.1, and then that's minus 0.18. So 1.1 minus 0.18, and then I get 0.92. So this is the size overall of the gaps, and there's 1, 2, 3, 4, 5, 6, 7, 8 gaps. So there's So there's 8 gaps, so I have to divide this by 8 to get the size of one gap. So 0.92 divided by 8, and then I get the size of one gap is 0.115, and that's 0.92 divided by 8. So yeah, so 0.92 divided by 8, and then I get 0.115. So it'll be 11.5 centimeters, but I just put it in meters. So be sure to state your units. And then it says the sphere. So this is part C, I think. And then the sphere on bar A. So they give us a diagram. So I'm just going to draw out roughly. So this is bar A, so these are the first two bars, and bar B. So the center of this is joined, and then there's a rod in between. So the rod is just outside the two of the circles, and then they're forming a right angle triangle here. So I was asked to get the shortest rod that will join them together. So what I'm going to fill in is I'm going to fill in what I already know. So I know what I'm already after getting is I know the radius of this bar is 0.01. So the whole diameter of the bar is 0.01 by 2, which is 0.02, and the whole diameter of this one is 0.02. I also know the heights already. I know the height of bar A, so I'm just going to deal in meters all together. The height of this bar is 0.713, because I told us this was bar A, and then the height of bar B, which I already got, was 0.803, so that's the height of bar B. I also can get the radiuses. So the radius of bar A, I was told in the first part was 3 centimeters. So then the radius in meters would be 0.03. And because I know the volume of bar B, because it was just the volume of bar A is 36 pi, and then the volume of bar B is by 1.75. So 36 by 1.75, so it's going to be 63 pi, and then that's the volume of bar B, a sphere B, sorry. So I'm going to get that equal to the formula for the volume to get the radius. So I'm going to divide both sides by pi. I'm going to multiply this side 63 by 3, so 189 is equal to 4r cubed. I'm going to divide by 4, so 47.25 is equal to r cubed. Then I'm going to get the cubed root of this, so 47.25, and then I get r is equal to 3.615. So that's in centimeters. So my radius is going to be 0. So I'll just see what do they want to correct to the nearest. They want to correct to one decimal place. So I'll put 0. So they ask for it in centimeters, but I have it in meters, but it'll be, we can deal with it after. So 0.03, as long as everything is in the same units, 6.2. So the radius of this one is 0.0362. So I am after figuring out this. So in order to get this, I'm going to need the distance in here, the distance here, and I'm going to need this here to form a triangle. So in order to get this distance, well, this distance here is literally just the radius and the height of this one subtracted from the radius and the height of this one. That's what that distance is. So the radius plus the height of this one is going to be the height, which is 0.713, plus the radius, which is 0.03. So 0.713 plus 0.03, and that gives us 0.743. So this is here is 0.743, and then this one here is going to be 0.803, and then plus 0.0362. So then I get the whole of this is 0.8392. So if I want to get what this length here is, the kind of the what this here is, it's going to be 0.8392 take 0.743. So 0.8392 take 0.743, and then I get 0.0962. So this here is 0.0962. But now I have to get what I need now is to, for a right angle triangle, I need to know what this is here. So I know that say the center of to get to the center of the cylinder, because it told me at the start of the question, labeled each ball with a solid sphere. The sphere is attached to the center, so the radius of the sphere is going to be at the center of this the cylindrical thing here, but the radius of the cylinder is 0.05. so how far in this actually is in compared to that? So this distance is going to be the radius of it plus 0.05. So so if you're looking to get the so the radius of it plus 0.05 and the radius, so I know the distance in between them. I already got the distance in between each, so I'll just get where I had that. So distance x is equal to 1 point, just getting the distances. So I got the distance in between each of these was 0.115. So if I want to get the distance in between the two centers, it's going to be 0.115 plus the radius of this one, plus the radius of this one. So 0.015, and I'm going to have to add the radius. Actually what I'll do is 0.015, because the center of it is just attached to this, the center of the circle is attached to the center of the cylinder. So 0.015 plus the radius of the cylinder by 2, 0.01 by 2. So it's going to be 0.115 plus 0.01 by 2, 0.115 plus 0.01 by 2. So this length here is going to be 0.135. So what now I have a right angle triangle, so it just looks a bit messy there now. So I got that this length here was 0.0962. This was here 0.135. So if I want to get this distance here, x, so x squared is going to be 0.135 squared plus 0.0962 squared. So x is going to be the square root of 0.135 squared plus 0.0962 squared. So square root of 0.135 squared plus 0.0962 squared. So squared. So then I get that x is equal to 0.16577 But this distance here is the distance, and it also counts the two centers. So the center of one of them is 0.0362. The center of the other one was 0.03. So I have to subtract. So 0.16577 subtract 0.0362 subtract 0.03. So 0.16577 take 0.0362 take 0.03, and then I get that the distance is equal to 0.09957. But they asked for your answer in centimeters, correct to one decimal place. So that's going to be 9.957 and then centimeters. So well, that's going to round to 10 centimeters. If we were to round it, had to put it to one decimal place, because it would just go to 10. So that is our answer for that. Thank you.